for ITM 510. My final project was called the SmartInk segmentation tool, where I actually take in a data file that was collected with a smart pen, and I show that data to the screen and make the user able to segment that data into different data classes and labels that I have set. This is for use with the MMSE, which is a cognitive examination that we use at the Alzheimer's Disease Center where I work. So first is the login screen. I'm going to log in with my credentials. In my write-up, I show you the failed attempts, but I'm just going to do a quick overview of everything hopefully working correctly. So I will log in. Yes, okay, and this is the main screen where the bulk of the user interaction takes place. So up here we have a file bar, a menu bar with file options, and a quick about, which just describes the project. So if I come over here to the file bar, I can open a file, which opens the file selection dialog, and I have some files saved. The sample files, which I will be including with my project, are collected from an actual smart pen, and they were collected today. I also have a video of the actual writing with the smart pen on a piece of paper that I will include after this demo. So as you see, I chose the file, and it prints the strokes from the pen to the screen. See all of them there. And it also populates the table view with stroke data. So each stroke from the pen, that is the amount of time the pen is pressed to the ink till the time it's lifted up, is saved here. I saved certain variables like the time that the stroke takes and the distance on the page. And see, I can select each stroke there just to see. Now, in my initial version, I had the user setting each stroke right here with the label select. That was very tedious, as you can see. There's about 50 strokes, and they would have to go one by one. In development, I found a clustering algorithm called dbScan, which stands for density-based clustering, accounting for noise, I think, but that's just, yeah, dbScan. So I implemented that algorithm to cluster the strokes together, and that just makes it a lot easier for the user. So if I hit this cluster button, see, it clusters the strokes with bounding boxes that are near each other. There's also some options here to change the parameters for the clustering algorithm, which is this is the distance of points, what it will consider into one cluster. And yeah, that's a little bit better. So that's 4 clusters that I need to segment instead of the 51 strokes. So if I click on this, it will highlight each cluster of strokes, and now I can label the cluster of strokes. That's research assistant data, that's a check mark. This is actual user data that we want to analyze, the sentence, pentagon, and RA data. Okay, and now we're ready to save. So we can write in the project ID. So it requires 8 digits and 2 digits for the follow-up year. And if you don't type that correctly, there are error messages, which I can just, if I try to save it, it alerts me that there's an error. And for most of these boxes, it has similar errors, or an error if I don't completely set all of the labels. The last is the sentence. There's not actually an error if I don't type the sentence, but it is for future development in recognition, character recognition that I can use with this program. So, and everything looks good. So if I hit save, yep, so it saves it, a CSV file to the same location where the raw file is. And in this dialog, I can score more or exit. I'll hit score more, and I will open the second file. You can see it's a little bit different, but very similar. And go back to strokes because no clusters are set. And I can cluster this one. Oh, clustering did not work so well with this one. A little bit more. There we go. Okay, so now, yep, just 4 variables again to set. Array data, sentence, and here I'm going to try to save it without setting the last cluster. So 1, 2, 3, 4, 5, 6, 7, 8. Follow up here, say 5. I'm not going to write a sentence, and if I try to save it, it won't, and tells me that I need to set the label at cluster 3. So now if I do that, this was array data, let's make sure, yep, and save, and that worked. And now here is the video of the digital pen data acquisition. I use a special optical pen that has a camera near the tip that can view a paper with a special dot pattern, and it can actually know the coordinates that writing has happened on the piece of paper. It looks just like a regular piece of paper with a little gray tint. We use this paper and special optical pen for the acquisition of MMSE data, that is the cognitive test data, at the Rush Alzheimer's Disease Center. And hopefully this project will actually be usable in that study. Thank you for your time.